After we've loaded and parsed our data, data transformation is the name of the game. We'll discuss array.map and array.filter, the set and map data structures, D3 min, max, and extent, D3 group and rollup, and bin for histograms, and finally pivoting a table. Array.map and array.filter are perhaps some of the most commonly used array methods. Array.map lets you apply a function to each and every item in the array to come up with a new array. Array.filter lets you specify a function that applies some sort of a test to each element of the array. And if that test returns true, then that item is included in the filtered array, and if that returns false, it's excluded. If you search for array methods on MDN, you'll find this awesome documentation of these methods that are built in to the JavaScript language. When you create an array like this, you're actually creating an instance of this array object that has a bunch of methods on it. The methods are listed here on the side. Here's array.map, which creates a new array populated with the results of calling a provided function on every element in the calling array. That means if we've got our array, we can call array.map and provide a function that, for example, multiplies each number by 2. Now we get this array of all the returned values. So each number is doubled. And there's also array.filter, which creates a shallow copy of a portion of the given array, filtered down to just the elements from the given array that pass the test implemented by the provided function. So if we've got our array, and let's say we want to just only include the odd numbers, we can say array.filter, passing a function that checks if this number is even or odd. If the remainder of d divided by 2 is 0, meaning if it's an even number, then this function returns true. When we run this, we get a brand new array that only contains 2, which is the only entry that passes the test. We could change 0 to 1 to isolate the odd numbers. That's a quick overview of array.map and array.filter. But how does this fit in with the stuff we've been doing with loading the data and the unidirectional data flow? Let me show you. I'll start by forking our loading data example, and I'll call it transforming data. This example we made earlier uses json.stringify to display state.data, which is an array of objects. Therefore, we can use these array methods on state.data. But remember, state.data could be undefined, loading, or an array. So before we do anything, we should probably check that state.data is not undefined, and it's also not loading. Now we can safely say data equals state.data, and we know that data will be defined as an array. And I'm just doing this so that we don't have to keep repeating state.data. I'm going to console.log data so we can use the console to explore the output of the code that we write. Let's say that we want to derive an array that just has all of the values for petal length. So this would contain 1.4, and then 1.4, and then 1.3, etc. Just mapping over all of these row objects. We can accomplish that with data.map. passing a function that takes as input one row and returns as output d dot petal length. Check it out, we've got this array of numbers. That's how you can use array.map to isolate the values for one specific column of your dataset. Now let's say we have a different problem. I'm going to console.log the original dataset again, just so we can see it. The value of species could be Setosa, versicolor, or virginica. Let's say we only want to look at species versicolor. To do that, we can use data.filter, passing a function that checks if the species is equal to versicolor. And check it out, I think it worked. The resulting array only has 50 elements. And if we take a look, they're all versicolor. No other values are in here for species. That's how you can use array.filter to isolate your rows of your dataset that have a specific value for a specific column. Let's talk about set and map. If you search for set in MDN, you'll find this documentation for the set data structure, which is built into JavaScript. The set object lets you store unique values. It's a lot like the set concept in math, where if you add the same value to a set multiple times, it only gets added once. It only keeps track of the unique values. This is very useful for initial data exploration for categorical columns because it gives you a quick way of isolating the unique values. For example, let's say we had no idea how many different species there were in our dataset. To find that out, we could make a new variable called species_set and instantiate a new set. And then for each row, we could call species_set.add d.species. And then console.log species_set. And check it out, it isolated our 3 values. An instance of set has a bunch of methods on it. And if you're ever wondering what they are, you can actually inspect the prototype in the dev tools and see all of them listed out. I'm pretty sure that set.values will isolate the unique values as an array. So if we type species_set.values, oh, it gives us a set iterator. Interesting. Well, I know if you want to create an array from a set, you can do it with array.from, which is super useful when you're dealing with sets and maps. Yeah, that worked. See, it gave us an array. By the way, there's a simpler way to do this. Rather than iterating over each element and invoking set.add for each one, for each species value, we can instead pass into the constructor of set an array that just has all the species values, which we can derive with data.map, passing a function that isolates the species values. Now we get the same result, but it's less code. That's how you can use set to figure out your unique values for a categorical or ordinal column. Let's talk about D3 min, max, and extent. These methods come from D3 array, one of the many D3 packages. D3 array contains all sorts of functions for dealing with arrays, such as d3.min, which returns the minimum value. Let's say we want to figure out what is the minimum value for petal length across all of our rows. Logically, step 1 would be to isolate just those numbers, and step 2 would be, based on those numbers, figure out which one is the smallest. We already did step 1 with data.map, a function that isolates petal length, which outputs this array. To figure out the minimum value here, we can first import min from D3 and then invoke that min function passing in our array of numbers. That will figure out the smallest value, which happens to be 1. That's one way you can invoke d3.min, passing an array of numbers. Another way this can be invoked is passing data as the first argument and passing that accessor function as the second argument. This has the same behavior and outputs 1. The term accessor function means a function that takes as input one row and then gives you a value for a particular column. Similarly, there's d3.max, which returns the maximum value. We can use that by importing max from D3 and just changing min to max. Now it outputs 6.9, which is the maximum value for the petal length column. It often happens that we want to know the min and the max at the same time. d3.extent computes the minimum and maximum value at the same time. If we call min and max separately, it actually has to iterate over the data twice. But instead, if we import extent from D3, we can change max to extent, and it returns an array with 2 elements, the min and the max. That's how you can use D3 min, max, and extent to figure out your minimum and maximum values. Let's take it to the next level with D3 group, rollup, and bin. D3.group also comes from D3 array, which groups the specified iterable of values into an intern map from key to array of value. The language can be a little tricky, but an iterable is basically an array, but there are other things that are also iterables that this supports. The group function returns this thing called an intern map. This is a D3 thing that extends the native JavaScript map, and it gives it some extra functionality around what's allowed to be keys. But basically it returns a map, which is an object that holds key value pairs. Here's a little taste of the map API. It's quite similar to set. You can create a new map and then call set, where the first argument is the key and the second argument is the value. And then you can call map.get, passing a key, and it returns the corresponding value. That's JavaScript map in a nutshell. And one of these is returned by d3.group. Here's a nice example. Let's say we have this data set where there's a name column that has different values. Stacy appears twice. To group the data by name, we can call d3.group, passing the data and an accessor that returns the name. And this produces a map where the keys are the name values and the values are arrays of row objects that have that value. Let's see how this works out with the iris dataset. First, we need to import group from D3. And what I'd like to do here is group these flowers by species. We can do that by invoking group, passing data as the first argument, and as the second argument, an accessor function for species. Sure enough, this outputs a map, or rather an intern map, whose keys are the various values that we can have for species. This is kind of similar to creating a set, but it also gives us those arrays of rows that have those values. So if I unpack the Setosa key here into its value, these are all of the original row objects where species is Setosa. And by the way, these values here, it's the same array that you would get if you used array.filter to isolate the rows that have species of Setosa. So now we learned something new about this data set. There are exactly 50 rows for each of the species values. So if we were to make a bar chart of this, all 3 bars would be the same size. That's how you can use D3Group to group your rows based on unique values for a categorical or ordinal column. By the way, there's another thing called flatGroup that has the same signature but returns an array instead, which is sometimes easier to work with because from here you can call .map and work on each of these entries using destructuring, where the first element is the key, the second element is the value, and you can do something like return a new object where species is key and count is value.length. Now we get a brand new data set where each row represents an entire species, and it just has the count for each of these. Summarizations like this is when D3Rollup makes sense to use. D3.rollup, which also comes from D3Array, groups and reduces the specified iterable of values into an intern map from key to value. For example, to count the number of elements by name in this data where we have different names and Stacy appears twice, we can say D3.rollup, passing in data, and the second argument here is the thing that summarizes the values. It reduces V here, which is the value, the array, to a summary of that array. For example, the count with v.length. The last argument here is the function that we pass into d3.group to figure out the groupings. This produces a mapping from the values to the counts. Let's try this out in our code. This code we've got here for computing the counts is pretty verbose and a little cryptic. What we could do instead is call rollup, which we first need to import from D3, passing the data, the species, yes, but in the middle we need to pass a function that accepts as input v, the value array, which is the same as this value here when it comes to the output of d3.group. And we want to do the same thing, just return v.length. Now we don't need this call to .map at all. This one invocation of rollup outputs pretty much the same thing. It's an intern map where the keys are the species and the values are the counts. There's also a variant of rollup called flatRollup, which we also need to import from D3. FlatRollup outputs an array of arrays, where each of the nested arrays is the key and the value, or the summarized value. This is pretty straightforward to transform into a usable data set by calling .map, destructuring that array, and returning a new object that has species and count. Now, what we have is an array of objects, which is essentially a new data table that only has 2 columns, species and count. You can use this pattern to implement all sorts of aggregation operators like min, max. This is count. You could also do average by modifying what this function here does. For example, What if we wanted to compute the average sepal length per species? To do that, instead of returning the length of the array of rows for each species, we can compute the sum of some value and divide that by the length to give us the average. And I think what we wanted to do is the average sepal length. D3.sum is another method from D3 array that just returns the sum of a given accessor function. We can use this by importing sum from D3, and we can pass data. Nope, we want to pass v, which is the array of values that match one specific species. So within that array, for that one species, we want to sum up the sepal length values. Now, instead of count, this is going to be the average. And in the output, I'll name this something like average sepal length. And if we take a look at the output, sure enough, it looks like it actually computed the average sepal length for each species. That's how you can use D3 group and rollup and sum to transform your data, computing aggregated results. Lastly, we've got D3.bin, which computes binned aggregation suitable for histograms. But how can that relate to our iris dataset? Let's say we want to really understand the distribution of sepal length. In addition to computing the min, the max, and the average, we can use D3.bin to come up with even intervals. We can do this by first importing bin from D3 and then using it like this. We first need to invoke bin as a constructor, which creates an instance of D3 bin. And then we want to call that function passing in our data. But this is actually not quite right, because what we should really do is just pass in all the sepal length values of our data, which we can do by saying data.map with an accessor function that returns d.sepal length. All right, so we're isolating the sepal length values, passing that array of numbers into this function that was returned by calling d3.bin. And it worked. Check out the results. It's an array of arrays, and each of these arrays has some new properties, x0 and x1. This describes the bin interval, where the bin starts, 4 in this case, and where the bin ends, 4.5. And if you look at these other bins, they're all increments of 0.5, which d3.bin figures out internally by looking at the extent of the numbers. We can use this output to generate a new data table that is suitable for use for rendering a histogram like this. We can say .map. I'll use v here to refer to the values array, and I want to return an object that has x0 as v.x0, x1 as v.x1, and count as v.length. Check it out. We have transformed our data into another data table where each row represents a summary of one of these intervals. So between the values 4 and 4.5, there are 4 rows. And between 4.5 and 5, there are 18 rows. This transformed data is suitable for direct visualization as a histogram. That's how you can use d3.bin to aggregate your data along a quantitative column using binned aggregation.